Did you ever hear of a green thumb? Yeah, I have the opposite of that. I have a black thumb. That happens quite a lot to me. You could give me a cactus and I would kill it in 2 days. So now it's time to do something about it. That's why I got this. Or not got this. Designed this. So this will be an automated plant watering system where you don't have to put any effort anymore to keep your plants alive. Hello, darkness, my old friend. So now the fun part begins. Assembling the electronics. So everything you need, you see it here. I also put a list down in the description below. Basically, it boils down to a pump, a measuring device for fill, like basically how much water you have left, motor shield for an AC motor, my loved Raspberry Pi Pico W's, a moisture sensor, and some random other electronics and printed parts. You find it in the list down below. So the first thing we want to do is we take one of our Picos and we put it in our Lazy Boy. We got 2 different kinds of battery department in this project. So you can decide which one you want to take. I go with the one with the 3 AA batteries, 1.5 volt each. So I basically gone ahead and put in a diode in the plus side of the battery. Diodes are these little small diodes. LED is a light emitting diode and this one is the boring sister of it. So it's a non-light emitting diode. It only lets electricity through one way. So we have to put one in this cable because I actually want to be able to provide electricity with the plug, but also with batteries. So whenever I unplug it, it will work off battery. Whenever I plug it in, it will automatically work out of my wall socket and the battery will be sustained. So that way you can, for example, leave for a longer vacation and be fine with switching off your circuit breaker, for example. So there is this possibility, but I also gone ahead and provided you guys with a battery compartment for a well-closed battery compartment for those alkaline 12 volt batteries. You can buy them in most department stores. It's very easy to assemble both of them. This one is just a little bulkier. That's why I've gone with the 3 AA batteries. And let's be honest, I normally have the 3 AA batteries lying around anyways. First thing we want to do is to bring electricity to the board. So for that, we have to find the pins that are actually marked with the name VSys. VSys is electricity through battery. Bus will only be under electricity when you plug in your USB cable. So for that, I bought these little plugs. So for this project, you want all your connectors accessible from this side. But because it's easier to read, I will actually turn it around. Our battery connector, I got these little pins or these little plugs here. Our battery connector goes into VSys and ground. So we quickly put it in there and I just fix it with my clamp. There, some soldering, some solder and quickly solder it to the board. So because we also use a battery, we of course want to measure how much juice is left in our battery pack. Because this one adds up to 4.5 volt and the Pico W can only take 3.3 volt on all of its pins. We have to build something to translate this current to the Pico without damaging it. This is where those come in. These are standard 330 ohm resistors. So what we're going to do now is we will build a voltage splitter. A voltage splitter is pretty easy. You basically have one wire where you have, in our case, 4.5 volts coming in. That would fry our board. So by placing a resistor here and another resistor to it, you get at the end, again, 4.5 volts. But in between, if you measure here, your voltage will be halved, 2.25 volts. So we will build this now on our pins to measure the current that's coming out of our battery pack. So then we can calculate if our battery pack goes below a certain threshold, we know our batteries are empty and we have to switch them out. So let's build that. The voltage splitter should be built between the VSys pin we just attached our battery pack to and the ground pin. And in between we then can measure on GP27 to ground. So let's take 2 resistors and let's build ourselves a voltage splitter. So I connected the plus of our battery to the pin GP27A1 here, and then another resistor I connected from GP27 to A ground. So what that actually does, it now puts our pin effectively in between those 2 resistors, voltage splitting the voltage on that pin. So you can actually now read out a half voltage on GP27. For our motor shield, we need some signal wires. So I actually pre-built this little cable here with a connector just to make it a little easier for me. And now we have to solder our connectors to the pins GP6 and GP7. So let's quickly finish that one up. So for the next step, you need this 3D printed part. I will provide the data to these parts, but they are basically like fitting to my pots. So you can redesign them themselves. Let's see, maybe I put up original CAD files to it. Feel free to remix it, but tag me in your posts or in your re-uploads because I want to see how far you can take that. With this, we will now mount our Pico in here because now the cabling work starts and we should have it in here just to see how long our cables have to be. On the top, I place one of those little connectors here. So the reason for doing that and not directly soldering it to the sensor itself is these sensors tend to rust a little bit. You can already see some oxidation on my test one here. So you should be able to quickly and securely switch them out. That's why I've gone for this plug. So the next thing is you want to do is basically you connect the first connector, the most outer one, to the pin GP26. Then you leave one free. You connect the next one to the pin 3.3 volts. And then the last one you connect to any ground connection on your Pico. So let's quickly do that. So we will place a LED up here. This LED has the function that it actually starts to blink whenever the battery is low or we don't have Wi-Fi connection or whatever, and you don't get any notification because if Wi-Fi is out, it can't give you a notification. So it will actually blink and give you a physical hint that something went wrong. We connect this LED to GP10. We do that with a 330 ohm resistor to not blow it because GP10 outputs 3.3 volts and this can't take it. Then the other side, we just simply go to any ground connection. Next is the sensor. It's mounted on this 3D printed part that goes in here, and we simply can mount our motor here, and it can be placed here. In here. And yeah. I love what you can do with electronics. I hate how complex it is to work with them. So last thing to do is the little cable I just explained you earlier is plugged in, and then you have to connect one of the pins to in2. The GP6 is actually connected to in2 and the GP7 to in1. And after that, the soldering job is done. So all you gotta do is take your package with the pump and the sensor, slide it in here, and screw it to the side. Put your lid on top and we're good to program. So now that we did all our electronic works and the manual putting together of the device, it's actually time to program our microcontroller. So for that, I actually had to evolve into a programmer.
We're not fully explaining the features here, the whole code, because it'd be super boring, but here's a quick rundown and all the settings you should know about. When you open the file main.py in your Thony editor, you need that to upload the code to your Raspberry Pi. You'll see the comments are everywhere. The code is pretty self-explanatory, I hope, but there's a quick rundown. At first we have Wi-Fi credentials, there's a Wi-Fi name and Wi-Fi password. We need that if your battery runs out or water runs out, so the thing can notify you by email. In email credentials, you put your sender email, which has to be Google, and recipient. Next, you have app pass, which is a token which allows a Google app to access your email and send you a notification. The app pass is a token that you get from Google to allow your app to send your emails in case of notification.
I will link a tutorial in the description down below how to set up this Gmail token. And if you have any issues with it, just leave me a comment down below and I will try to help you.
The next thing you can set up is spin duration. This is how long your pump stays on, aka how much water will be pumped at once. After that, there's like a few settings you can tweak. Here you can tweak how often it checks the moisture level. We use a feature called light sleep here that puts your device into very low energy state to conserve a battery life. The times are written in milliseconds. I explain it real quick. Sleep after pump is the time after a successful watering and the time before it checks it again. So when it pumps, then you check the moisture level. That gives the water time to saturate the soil. So after you put the water in it, it goes in and reaches the sensor, so you don't overwater the plant. Sleep moisture good can be as high as possible in terms of time because it's in milliseconds. Your plant has enough water now to wait, and such that we also wait to conserve electricity. Unfortunately, there is a limit, only 4320000 milliseconds. Wi-Fi failed is the time before it retries connect to your Wi-Fi network in case, well, it just failed, and it will retry after some time. Error flash controls the time in between flashes on onboard LED, so if something went wrong, it starts to flash, tries to inform you something went wrong. For example, if it tried to connect to Wi-Fi network for 3 times and failed, it starts flashing LED to you. The next important thing is the moisture threshold, because here we control how wet the soil gets before we stop watering it, and how dry it needs to get before we start watering it again.
Oh, sorry about that. So, because these sensors actually have some tolerances to them, I personally would give you the tip to calibrate them yourself. So I wrote a little script, you can find it in the description down below, which is just called test moisture. And all you do is you basically take a plant where you're on the moisture level of I would water it again now. Please take your normally I would water it again now and not like, oh, I forgot for 2 weeks to water my plant. So basically you stick in your moisture sensor. That's what she said. And you can read a number off the screen. So you have this little window down in Thony where it shows you something called shell, and in the shell it will do a graph on the levels. So you basically stick it into your dry soil on the brink of where you would water your plant again, and you simply put down that number. And so you basically just stick your sensor into the soil,
or he said,
on the point where you would water it again, and note down the number it shows you. It will fluctuate a bit, but just take the best guess you can get. And then you go ahead and water by hand your plant again. You give it about 30 minutes or so for all the water to really seep in and like For real? Now? And then you mark down the maximum level. So these are now your min and max moisture thresholds.
So the first number you got is a min threshold, and the second number is a max threshold. I would suggest to go a bit lower on the maximum setting once it takes more time to saturate the whole soil than we actually wait on a pause. And that's actually a code already. The rest, it's actually business logic, functioning part. You can read it through and, of course, make edits as you like. I just provided comments everywhere. Now let's put in your microcontroller, your Raspberry Pi. So now it's time to plug in your fresh Raspberry Pi controller into your computer. I could use that one, but since that's already programmed, it will start to water. You plug into your microcontroller and it will show up as a USB device in your Tony editor. Here you simply drag and drop your file, which is called Raspberry Pi Pico w blah 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 .uf2, which is a file of firmware, and device will disconnect electronically. You won't see it anymore, but that means it's programmed. And then after a while you'll see a reconnect. There won't be any flash drive anymore. That's normal, that's fine, that's how it should work. Now you go to Tony editor and run configure interpreter, choose MicroPython, because we code in Python, or microcontroller. Up here you select specific port or try to detect automatically. If Tony cannot do it, click on device in a list and just add it manually. When you successfully connected your board to your computer, the shell down here will show you the information from your board. It will basically stream the serial port through a USB to your computer. And use Tony to upload the file umail.py to the board. After that, save main.py also to the board. You also see a flash_nuke uf2 file in the files you downloaded. That's a thing which will help you to reflash your Raspberry, because when we use that energy saving feature like light sleep, it actually breaks something in a USB. So in order to connect it once again to your computer and be usable, you have to first put a flash_nuke. It will erase everything on the flash memory of a device. It will function properly now, like as from a factory. That's a feature of light sleep now.
So now that we actually programmed everything and we have our electrical work done and we put everything together, let's go and test it out. As you can see, it works wonderfully. So this one is the first version of it. I want to do a few updates. For example, I want to add an e-ink screen where you can see the moisture level currently in your plant. I also want to add two potentiometers so you can adjust the thresholds of your moisture graphically on the part to make it easier to calibrate your device when plugging it in. And if I already got to do that, you can find that video here. If I haven't, you find another video for you to watch. So see you next time then.